this video, we will be discussing about minimum length of string after operations. You are given a string S. You can perform the following process on S any number of times. Choose an index I in the string such that there is at least one character to the left of index I that is equals to S of I, and at least one character to the right that is also equal to S of I. Delete the closest character to the left of index I that is equal to S of I. Delete the closest character to the right of index I that is equal to S of I. Return the minimum length of the final string S that you can achieve. So what they are saying is that in the input, we are given a string S. Now in this particular string, we can choose an index I. Let's suppose I choose this particular index. Now this index should have character towards its left, which is equal to this particular character, and a character towards its right, which is equal to this character, right? So basically, if I choose this A, then towards the left I have an A, and towards the right also I have an A. But I cannot choose this A. Why? Because towards the right I don't have any A for this, right? Now once we have chosen such a character, then what we can do is that whatever is the closest A towards its left and closest A towards its right, we can delete them, right? And we can perform this operation any number of times. Now what we need to return is that once we perform the operation any number of times and we delete some of the characters, then what is the minimum length of this string that we can get, right? That minimum length we need to return as our answer, right? So in this particular case, what we can do is first we can choose this A. If we choose this A, then we can remove this one and we can remove this one, right? So our new string will be BAC, BC, B, right? Now what we can choose? We can choose this B, right? So we can remove this B and this B, or we could also choose this B, right? Then we could remove this B and this B, right? So let us suppose that we choose this one. So the new string will be A, C, B, C, B, right? This B and this B got removed. Now, can we choose any character over here? For this A, I don't have anything towards the left. For this C, I do have a C towards the right, but no C towards the left. For this B, we have a B towards the right, but we don't have a B towards the left, right? So, this is the minimum length string that you can get. Its length is 5. So, for this particular string, our answer is going to be 5, right? So, this is what we need to do. So, if you quickly see over here, what we did was that first we selected this A and then we removed these two A's, right? So if I just write over here, when I was having three A's, I chose the middle one and I removed these two, right? So this one remained. And now the new string is just this A. Now this A cannot be removed because there is nothing towards its left or right, right? So from this string, its contribution towards the minimum length will be 1 because there will be one A remaining after we apply our operations, right? Now let us suppose that A was present 4 times. In that case, what would happen? We could choose this A and we could remove these two. So the new string would be AA. Now can I choose any A? No, right? Because if I choose this one, nothing towards the left. If I choose this one, nothing towards the right. So this is the minimum string that we can get, which is of length 2. So when we had 4 A's, its contribution towards the minimum length would be 2, right? Now, if let us suppose that I have only one A, can I remove this? No, right? So this will contribute a length of 1. If I have two A's, can I remove them? No. So they will contribute a length of 2, right? So the key observation over here is that when the frequency of a particular character is odd, right? Here it is 3, here it is 1. So whenever the frequency of a particular character is odd, then its contribution towards the minimum length of our string will be 1, right? If we see one more example, that if let us suppose that A is present 5 times, in that case what you can do, you can choose this A. So these two will be removed, right? So new string will be like this. Then you can choose this A and remove these two. So the remaining one will be only A, 1A, right? So again, when the length was 5, the contribution is 1. So whenever particular character is having an odd frequency, its contribution will be 1. And if we see for the even case, here the number of A's are 4, right? So it is contributing 2. When it is 2, then also it is contributing 2. If let us suppose that we have 6 A's, right? In that case, I could choose this and remove these two. So the new string will look like this, right? Then I can choose this one and remove these two A's. So I will be getting this string. Now this string, we cannot apply operation over this string further. So this will contribute a length of 2, right? So whenever we have an even frequency, then the contribution is 2. So this is the observation that we have made. So what we can simply do is that from our string S, we can identify the frequency of all the characters. So here we are having A, B and C, right? What is the frequency of A? 1, 2 and 3, right? Then what is the frequency of B? 1, 2, 3, 4. And what is the frequency of C? 1 and 2, right? So now the frequency of A is odd, so this will contribute 1. Frequency of B is even, this will contribute 2. Frequency of C is even, so this will also contribute 2. Now if you sum up all of these, what you will get? You will get a 5, which is the answer in this particular case, right? So that is what we need to do. We can simply create an array or vector of length 26 because we are only having A to Z characters in our string S, and in that we can update the frequency of all the characters, and then we can take an answer variable, and in that answer variable, whenever the frequency is odd we can add a +1, and whenever the frequency is even we can add a +2. That's all what we need to do. So here we would be iterating one time in this string S for updating this vector, and one time in our vector which is of length 26, right, for finding out our answer. So the time complexity would be order of n into 26. 26 is constant, you can consider it as O of n. And for the space complexity, we will be taking a vector of length 26, so we can say it will be order of 26 or constant. So let's quickly look at the code. So first of all, let's create the frequency vector. This will be of size 26, and initially all the values will be 0. Then we'll take an answer variable which will be 0 initially. Now we need to update the frequency of all the characters in string S into the frequency vector, right? So for character ch in string S, what we will do in the frequency vector at the index character -a, we will do plus plus. Once we have updated the frequency of all the characters, now we will iterate in this frequency vector, right? So for int f in frequency, so this will give us the frequency. Inside this, if the frequency of any character is 0, then that means that character is not present, right? So in that case, we will just continue, right? Otherwise, we will check that if frequency modulo 2 is equals to 0, then that means it is even. So in the answer, we will add a 2. Else means frequency is odd. So in that case, in our answer, we will add a 1. And at the end, we can return this answer. So let's run this now. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.